Okay, looking at problem 4 here. How does the graph of k of x, which equals 5 times x minus 2 cubed plus 4, compare to the graph of the parent function? First, I want to identify the component parts of k of x. This coefficient out front is your a value. The 2 inside of the parentheses is your h value, and the 4 that's out at the end, that's your k value. What I have left is x cubed. So our parent function is x to the cube, x to the third, right? This is a cubic parent function. I'm now asked to list the different transformations. So let's go one by one. I'll start with the k. We know that k values represent vertical translations. So this graph is vertically translating the parent function of x cubed. And since k is a value of 4 and it's being added, I know it's going to vertically translate in the up direction by 4 units. Okay, we've got our k value. Let's move on to h. Our h value is a horizontal translation. All right, and since we are subtracting 2 units, we know that that is going to horizontally translate in the right direction, rightmost direction, so a positive x direction of 2 units. And lastly, we have an a. So the a is positive, right? It's 5. So where there's no reflection, but a represents a stretch in this case, because the absolute value of a is greater than 1. So this graph is going to be stretched by a factor of 5. Let's take a look at the graphing calculator and see what this does. Right now, this is a graph of the parent function, f to the third. If I move k to a value of 4, you can see that it gets vertically translated upwards by 4 units. If I move h then to 2, you can see that it moves to the right by 2 units, horizontal translation. And then if I move a from 1 to 5, it's vertically stretched. And that's what k of x should look like on your graphing calculator.